Hello everyone, welcome back to Piece of Physics. In this particular video, we are going to see like how object moves under the gravity. If you know that Newton discovered gravity using like he was sitting below the uh, apple tree and suddenly the apple fell in front of him. Okay, so that's how people say that gravity was discovered. Okay, so now let us see how motion under the gravity works. Okay, like how object moves under the gravity. Okay, so our topic is free fall. Okay, so free fall is the motion of object under the gravity. Okay, so here consider one planet. Basically, we live on the Earth. So suppose this is the Earth. Okay, and this particular part is the radius of the Earth. Radius of the Earth is 6400 kilometer. Okay, now let us consider one object over here. This is the height of the object from the surface of the earth, right? So here the height is basically in meters, hundreds of meters, right? So here h is basically less than in earth. Okay? So here the radius of the earth is too much large compared to the height of the object. Okay, so in such cases the x whenever object is moving under the gravity, basically gravitational force is being applied on the object, so that means the object will is going to accelerate. Okay, so acceleration due to gravity is basically small g equals to gm upon r square. Okay, so basically acceleration due to gravity is 9.8 meter per second square. Okay, in centimeter you can write it as 980 centimeter per second square. Okay, so if sometimes value of g is taken to be 10 meter per second square because it's nearly equal to the 10 meter per second square for the convenient to calculate the numerical, right? So whenever if it is stated that take g equals to 10 meter per second square, then we are going to take g as 10 per second square. Otherwise, in most of the numerical, we are going to take g's value as 9.8 meter per second square. Okay. So now let us see how we are going to apply the convention. Basically, object can move under the gravity like downward, and we can throw the object upward, vertically upward. So in these cases, how we are going to apply our convention to the velocity and acceleration. Basically, in each case, we are going to take value of g as minus 9.8 meter per second square. Okay, velocity for upward is taken as positive, downward is taken as negative. Okay, if object is released from some height, then the value of initial velocity is taken to be 0. Now consider this particular tower. Okay, so here consider a person who is standing on the tower. Okay, and he has a ball in his hand. Okay, so whenever object moves downwards, okay, so downward displacement is always taken as negative, and upward displacement taken as positive. Okay, so basically this particular line is taken as the reference line. Okay, so basically below the reference line the displacements are taken as negative, and above the reference line displacements are taken as positive, right? So that's how we are going to apply our convention to each and every numerical which is based on the gravitational force. Okay, so So before solving the problems, we are going to see few general cases like how object will travel vertically upward and how object will travel vertically downward. So let us have some cases. So our first case is if object is thrown vertically upward from the ground. Okay, so consider this guy, which is our Bob the Baller. Okay, so he is throwing the ball, so that's why he's Bob the Baller. Okay, so here you can see that to throw the vertical object vertically upward, we need some initial velocity v naught. Okay, and at the highest point, object is at rest. Okay, so whenever object reaches the maximum height, it is going to be at rest. Okay, now for some time the object is going to rest, and after that moment it is going to fall backward. Okay, so it is going to come downward. Okay, so here you can see that we generally take downward velocity as negative and upward velocity as positive. Okay, during this motion, upward motion, basically this is known as ascent. Okay, and when your object is traveling downward vertically, it is known as descent. Okay, so let us first consider the case of the ascent. Okay, so initial velocity is taken as positive, so u is our initial velocity, which is v naught. Acceleration is minus g. Up now the displacement is upward. Okay, so we can take this height as h, so upward displacement is plus h, and at the maximum height object is going to be at rest, so the final velocity is going to be 0. Okay, now we are going to first calculate time of ascent. So basically we have equation v equals to u plus at. V is 0, this is v naught minus g t ascent. Okay, so basically time for ascent is taken to be v naught upon g. Okay, so that's our first top point of ascent. The time for the ascent is going to be always v naught by g. Our second our second parameter is going to be maximum height. Okay, now we have equation v square minus u square equals to 2ad. Okay, our final velocity is 0 minus v naught square because u is v naught. 2 acceleration is minus g and d is taken as plus h, so h is going to be v naught square by 2g. So our maximum height is going to be v naught square by 2g. Okay, so we are going to find two parameters, one is time and the second one is maximum height, because that's what we all need. Okay, now let us consider the case of descent. Okay, in case of descent, now the object initially at rest, so u is taken to be 0, final velocity is taken to be minus v naught, and displacement is downward, so the height will be minus h, and acceleration is always negative, which is minus g. Okay, so first we are going to find the time. The time for is descent. Okay, so now v is minus v naught, u is 0, minus g t descent. Okay, so time for descent is going to be v naught by g. Okay, and our second parameter is going to be height again. Okay, so height is going to be same as earlier. Okay, so we don't need to find this particular thing. Okay, now let us find what will be the velocity at the beneath, which is going to be always minus v naught. Okay, so that's all for ascent and descent. So time for the ascent is same as the time for the descent. So it means if object is traveling upward, so it will reach the maximum height in 2 seconds, and it will come back after the 2 seconds. So total time for the journey is going to be 4 seconds. Okay, so is going to be always equal to time for descent. In case of negligible air resistance. So that's what we have to remember. Okay, so here we are going to consider that there is no air resistance in the atmosphere. So in this case is so in this case time of ascent will be equal to the time of descent, right? Now I am going to consider this case as a single journey, ascent plus descent. So I can name this topic as ascent plus descent. Okay, so here you can see that initially the velocity of the object is v naught, and final velocity of the object when it comes back, then it is minus v naught. Okay, so displacement of the object is 0 and u is v naught. Okay, so distance or displacement is going to be ut minus half gt square. Okay, so this is 0, u is v naught, t minus half gt square. Okay, so basically it will be, time will be 2 v naught by g. Okay, so here you can see that total time is the sum of time of ascent plus time of descent. Okay, so total time is always going to be 2 v naught by g. Okay, okay, so here now we are going to plot a graph of velocity versus time for this particular motion. Okay, so initially the object has the velocity plus v naught. It decreases linearly with the time, and at certain moment it is going to be 0, and after that it is going to increase in negative velocity. Okay, so the value of velocity at this point is going to be minus v naught. Okay, so here the time. Okay, now let us look into the time. So time for reaching upward the maximum height is going to be v naught by g, and time for coming back to the initial point, it is going to be 2 v naught by g. Okay, so this particular area. Okay. Now as we know that velocity time graph area give us the displacement. Here the base and we have height. Okay, so the area under this curve is known to be distance. Okay, so here the height is v naught, half v naught into base. Okay, so this is going to be v naught square by 2g. So distance is basically v naught square by 2g, and here it is going to be, you can name it as 2, you can name it as 1, this minus v naught square by 2g. Okay, so total displacement is going to be 0. Okay, so you can add this d1 and d2, and total displacement is going to be always 0. Okay, so that's all for this particular theory. In the next video we are going to see if object is being thrown vertically downward from some height, in that case what is going to happen. Now stay connected to the channel for further videos. Thank you so much.